section 1.1, Square and Cube Numbers of the IGCSE Math Coursebook. First of all, we're going to start off with a simple question. What is a square? Well, a square is a quadrilateral with 4 equal sides, like that. It has a side length of x, and here's a question for you. How do you calculate a square's area? So you're able to calculate it by the length of one side multiplied by itself. So x times x, or in other words, x squared. So this is the definition of squares and square roots. So a square is when you multiply a number by itself. The symbol is x and a small 2 up there, which means the power of 2. It's similar to how you calculate the area of a square, basically. So here are some examples. The square of 5, or 5 squared, is 5 times 5, which is equal to 25. The same with 6, which is 6 times 6 equals 36. Next up, we have the square root. The square root of n is the number that is multiplied by itself to get n. The symbol is square root of n. The square root of 9 is 3 because 3 times 3 is 9. The square root of 25 is 5, square root of because 5 times 5 is 25. The square root of n squared is n because n times n equals n squared, and so on and so forth. Next up, so what is a cube? Well, a cube is a 3-dimensional shape, the 3-dimensional version of a square. That is what a cube looks like. And so, how do you calculate the volume of a cube? Since this is a square, right? And all the sides are equal, we just take x multiplied by itself 3 times. We just take the length of one side, multiply it by the width, multiply it by the height, the length, and then you get the volume. So, in other words, it's x to the power of 3, or x multiplied by itself 3 times. So, here's some definitions you should remember. A cube is when you multiply a number by itself 3 times. The symbol is x to the power of 3. For example, 5 cubed, 5 times 5 times 5, can be written as 5 to the power of 3. The cube root of n is the number you multiply by itself 3 times in order to get that number. The symbol is a tick next to an x with a small 3 on top of it. Thank you.
In this part of video, we will talk about multiple of whole number. First, what is the definition of whole number? Whole number is a number without fraction or an integer. We can also say that whole number are positive number, including 0. In the picture, we can see that whole number are numbers like 0, 1, 2, and 3. But 25, 2000, or 100 are also whole number. Next, we will talk about multiple. Multiple is a number that can be divided by another number without a remainder. For example, multiple of 10 are 20, 30, 40, 50. That means 10 can be divided by 20, 30, 40, 15 without a remainder. And also 6, 9, 12, 15 are multiple of 3. To find the multiples of a whole number, you take that whole number and multiply it with any counting number. For example, to find the multiple of 5, you take 5 and multiply it with 1, 2, 7, 12, and any counting number, and you will get the multiples of 5.
Moving on to the next topic, factors of whole number. Now, factors of a whole number is any whole number that divides into exactly. For example, factors of 10 are 1, 2, 5, and 10. Note: 1 is always a factor, even for the number itself. Now, when we find factors, we must always find it by factor pair. For example, 2 times 10 equal to 20. Therefore, 2 and 10 are both factors of 20, and 2 and 10 is a factor pair. How to find factors? Step 1. We know that 1 and the number itself will always be the factors. Step 2. Use the divisibility rules to find the smallest prime factor of the number, and from that find factor pairs. Step 3. Keep dividing it by slightly larger prime number until the factor pair starts repeating. For example, factors of 10. Factor pair number 1 will be 1 and 10. Factor pair number 2, 10 is divisible by 2 since it has 0 as unit. Therefore, factor pair number 2 will be 2 and 5. Factor pair number 3, 10 is divisible by 5 since it has 0 as unit. Therefore, factor pair number 3 will be 5 and 2. The factor pair repeats, so the factor of 10 are 1, 2, 5, and 10.
This is chapter 1.4 about prime numbers. To begin with, we should know what prime numbers are. So, to put it in a simple way, they are whole numbers that have exactly two factors, which is 1 and itself. For example, 2. It is a prime number because it can only be divided by 1 and 2. Something that we need to keep in mind is that 1 is not a prime number because it only has one factor, which is itself. Time for some questions. Question 1. Decide between these numbers which are prime and which are not. So first, let's look at the even numbers, which is 462, 108, and 848. So obviously, even numbers cannot be prime numbers except 2 because they are divisible by 2, which leads to many other numbers, so we can eliminate it from prime numbers. Next is 365. Its unit number is 5, so it can be divided by 5, therefore it's not a prime number too. 711. If we add all its units together, we get 7 plus 1 plus 1 equals 9, meaning that it is divisible by 9, as well as 3. It's not a prime number. And the final one is 0. It's also not a prime number because it can be divided by infinite amount of numbers. The second one, Johnny has 31 bottles of dish soaps. His grandma wants to arrange it on a shelf in rows with the same number of dish soaps. Johnny argues that it is not possible, but his grandma insists that it is. Who's right here and why is that? So first we need to know whether it is probable to arrange 31 bottles of dish soaps into equal amounts on shelves, and the answer is yes, but they will either need to arrange it by 1 bottle on each shelf or 31 bottles on one shelf. So Johnny's grandma is the right one here due to two ways of dividing the number of bottles of dish soaps, which is 31 and 1. Chapter 1.5 Prime Factorization. Facts. Every whole number that is not prime can be written as the product of prime factors. For example, 35 equals 5 times 7. 40 equals 2 times 2 times 2 times 5, or 5,929 equals 7 times 7 times 11 times 11. So we can see that 5 and 7 are the prime factors of 35, 2 and 5 are the prime factors of 40, so are 7 and 11. So finding this way is really time consuming and hard to interpret, so another way to write it is to use indices. Instead of writing 2 times 2 times 2, we can write it as 2 to the power of 3, so 40 will equal to 2 to the power of 3 times 5. This way of writing is called prime factorization. Time for some questions. Question 1. Lucas has 6 times 3 bottles of dish soap. Is it possible to write the number of dish soaps as prime factors? If it is, then do it. So first we need to know whether it is prime number or not, and based on 6 times 3 equal 18, then it is not a prime number, so we can prime factorize it. And the way we do it is we divide it into smaller numbers. In this case, 6 times 3 can be written as 3 times 2 times 3 and 3 to the power of 2 times 3. That is the prime factorization of Lucas' bottles of dish soaps. Question 2. Use the fact above to prime factorize 900. We can see that 900 is twice as 450, so the prime factorization equation would be 2 to the power of 2 times 3 to the power of 2 times 5 to the power of 2. Write 1800 as a product of prime factors. So we can see a similar trend here, which is 1800 being twice as much as 900, so we need to double the amount of 900s, which leads to the equation that we have is 2 to the power of 3 times 3 to the power of 2 times 5 to the power of 2. C. Write 1350 as a product of prime factors. We can see that 1050 is triple the amount of 450, so we need to times the original equation by 3. We ended up having an equation which is 2 times 3 to the power of 3 times 5 to the power of 2.
Today we'll talk more about the highest common factor and the lowest common multiple, which we use the prime number to find out the highest common factor and the lowest common factor of two or more number. Moving on, we have the very first example here. We have 810 and 252 as two number. Now we prime factorizing them, so I get 810 will equal to 2 times 3 square 4 times 5. 252 will equal to 2 square times 3 square times 7. So for the highest common multiple, we multiply the prime number which occur in both lists, and if they have the same number but different index, we choose the one with the lowest index number. For example, we have 2 and 2 square. 1 is smaller than 2, so we take 2 as the number 2. And we have 3 square 4 and 3 square. 4 is larger than 2, therefore we have 3 square as the representative number 3. And for 5 and 7, they occur in either of the list but not both, then we don't have them here. So for the highest common factor, we'll have 2 times 3 square will equal to 18. For double checking, you can have 810 divide by 18 and 252 divide by 18. If they are both divisible, then that is the right number. Moving on, we have the lowest common multiple. They are the multiple of the prime numbers which occur in either of the lists. And if it have the same number and different index, choose the one with the highest index number. So in here we have 2 and 2 square, which is 2 square is larger than 2, so we have 2 square here. And 3 square 4 and 3 square, we have 3 square 4 is larger than 3 square, then we have 3 square 4. 5 and 7 occurs in either of the list, so we have them both down here. For the lowest common multiple, we have 2 square times 3 square 4 times 5 times 7, which is equal to 11,340, which we can also double checking it by have 11,340 divided by 810 and 252, which if they are also divisible, this number here will be the lowest common multiple. In chapter 1.7, we're talking about the real number. I'd like to begin the lesson with a little bit drawback from what we have learned before. So we have here the natural number, which are the positive number and the counting number. The whole number, which is all of the natural number and 0. The integers are all of the whole number and their opposite. So technically, the natural number is the smallest set, then the whole number, then the integer set. Now today we'll learn about the largest set, which include all of those three sets, which is the real number. The real number is split into two main types, which is the irrational and the rational number. The rational number are the integers or fraction. We have an example as minus 17, 1/4, square root of 9, 0. Secondly, we have the irrational number, which cannot be written as a fraction. They are the non-terminating decimal with no pattern. Such, we have an example, square root of 2, square root of 17, and pi number. Thirdly, we'll come to the reciprocal number, which basically is 1 dividing by a number which is not 0.